remember how cows help shape international measures? In short, the measure of the grass needed to feed a cow is the ancestor of the meter, the international standard for distances. You might remember that the definition of the kilogram changed too? Will the new definition of the kilogram help your next diet? Let's go back in time for a minute and see how the kilogram evolved over the years. When it was first defined, the kilogram was said to be 1 litre of pure water at 4 degrees Celsius. But since it is difficult to measure 1 litre of water very precisely, it was decided that the kilogram would get a new definition: the international prototype of the kilogram. Basically, this is an object of 1 kilogram made in 1889 and locked in a vault somewhere in Paris ever since. Over time, this prototype got handled and ended up weighing around 50 micrograms less than the original kilogram. Of course, it doesn't change much on your scale every morning, but for scientists working with very small weights, it is important to be extremely precise. It was time for a change. We needed a basis that wouldn't evolve over time. This was provided by physics and discovered by the German physicist Max Planck at the beginning of the 20th century. It is logically called the Planck's constant, and the kilogram is now defined according to it, and it is worth exactly this. The constant links the energy carried by a photon to its frequency and is expressed by 3 standard international units: the meter, the second, and the kilogram. Since the meter and second are constantly expressed as natural constants, using Planck's constant allows us to define the kilogram without any physical reference. A new definition that is thus absolutely precise, no matter what the time or space. Now, why did it take so long to change the definition? Well, first, the constant is small, very small. So small, it starts with a decimal point followed by 33 zeros. It is one of the smallest numbers in physics, and as such, it is extremely difficult to measure. It was decided to use a very sophisticated balance called the Kibble Balance in memory of its inventor, Brian Kibble. It aims at equating the mechanical energy exerted by the mass of an object on one side of the balance to its electrical power on the other side. This is such a precise thing to do that it needs to be located deep underground on a concrete floor that isolates the equipment from any vibrations from the building. To make things even more precise, the balance was replicated all over the world to measure Planck's constant and compare the results to make sure there would be no difference. A truly worldwide effort for a unique and time-proof definition of the kilogram. Good news for science.